Now, my students, let us proceed with today's lesson. Our today lesson is sound wave. We're going direct to see what is sound waves, but I think remember in our study of longitudinal waves, one of the example of longitudinal wave was sound waves. Now today we're going to look deeply what is sound waves and most of things concerned about sound waves. To begin with, let us define what is sound waves. A sound wave is nothing but the longitudinal waves that are produced by vibrating objects. The longitudinal waves that are produced by vibrating objects, the object which vibrates back and forth, back and forth, back and forth, when those objects are disturbed, is called sound waves. And among of the example of those objects are tuning fork. This is the laboratory objects, and the guitar. I think you know the guitar normally used to produce the music, and we have many objects which produce sound waves. But the good thing which you want to know here, sound wave first of all is the longitudinal waves. Not only the longitudinal waves produced by the what? Vibrating objects. Now from the definition, we had this concept here. Sound wave is a longitudinal waves. What does longitudinal wave tell us about? Due to the fact that sound wave is a longitudinal wave, this means that sound waves takes place in all medium, due to the fact that sound wave is longitudinal. Remember, longitudinal waves takes place in all mediums. Sound wave is the longitudinal waves. That sound waves can take place through all mediums. That is, can take place through solid, can take place through liquid, can take place through what? Gases. This is a sound wave. Why this? It's because under longitudinal waves needs only volume change in volume. The media should change in volume. We call it volume elasticity. For the formation of longitudinal waves, who is the example is sound waves, we need volume elasticity, not shape elasticity as in transverse waves. Now, due to this factor, that's why in solid there is change in volume, in liquid there is change in volume, gaseous there is change in volume. That's why longitudinal can take place all those three states of matter. And among of the example of longitudinal is sound wave. Due to this also, sound wave can take place through all the three states of matter. Now this is all about the definitions and what we should do with definition of sound waves. I think from that point you have understood. Another thing which you should learn under sound wave is the sources of sound waves. We have, as I said, we have many sources of sound waves. But the following are some of the following. Example of sources of sound wave have people. For example, as I'm talking here, I'm producing sound waves. Animals, cats, for example, cats, horses, those produce sound waves. Plants, we have machines produce sound wave. We have music instruments such as guitar. All these can produce what? Sound wave. Therefore, these are sources of sound wave. We have many. I think you can continue mentioning the source of sound waves. After learning After knowing the source of sound waves, now we want to know how sound wave propagate from one point to another. That means the mechanism of sound wave to move from one point to the next point. How sound waves travel from one point to the next point. This question also can be asked. Now we are going to look propagation or transmission of sound wave. How sound wave is transferred. Remember, sound wave is what? Sound wave is the longitudinal wave. Longitudinal wave is what? Longitudinal wave is the mechanical waves. Mechanical wave behavior needs what? The mechanical waves needs matter or particles for it to propagate. Now, like other mechanical waves, sound waves also needs particles. For it to transfer from point A to Z, it needs particles to vibrate. Now, how these particles they are going to transmit sound waves? This is we are assuming these are the particles under certain medium, which when will be disturbed will transfer sound waves. How? Assume now we disturb this point here, either by striking it, we struck it or hammering it. What will occur? This particle will vibrate. And remember, for the case of longitudinal waves, the vibration is back and forth, back and forth, back and forth, but about its fixed point. Therefore, this particle will vibrate forward and backward, but under this area, under this what? Area, will go forward and come back. Now, during the mechanism of going forward, will cause this particle will the struck particle, after being struck, will go forward and go back again to its original position. But during the way of going forward, it will cause this particle also, it will disturb this particle. Therefore, this particle will go also forward, but again will come back to its original positions. When this particle go forward, will disturb the next one. Do you see? Do you see? Now this particle, after being disturbed also, will go forward and back again to its original position. This will disturb, Therefore, this is like a chain. This disturbance will be like a chain, where through this chain, we are going to produce the sound waves, which is of a series of compressions, and rare functions, compressions, and rare what? Rare functions. This is how sound waves is being produced from the first point to the last point by vibrating the medium back and forth, back and forth, back and forth, back and forth. Now you'll be asked, briefly explain how sound waves is transferred from one point to another. The answer is simple. It's through vibrating back and forth the particles of the media. One particle will disturb the next will disturb one another, until when these waves reaches the target, until when the wave reaches what? The target. This is how sound waves can be transmitted from one point to another. We have said that sound waves can be transferred from all medium. That is, can be transferred through solid, can be transferred through liquid, can be transferred by gases. But the speed of transmission is the same in all states. We are going to see if at all the sound waves will be transmitted equally through all states, or we are going to learn otherwise. Now let us look this one. Our heading is saying media and sound wave. This is this heading I just like put like that. I just designed this way: the media and sound wave. The media I'm talking about are the three states: solid, liquid. This is, let us assume this is gas, this is liquid. Now, do you see the particles arrangement for the solid, for liquid, for the gases? Now, we want to see, even though if the particle arranged this way, but the transmission will be the same or different. For the solid, the particles are very close to each other. This means now the transmission from one point to another is quick, because this once vibrates will go forward, will cause this one to will disturb the next will disturb. Therefore, disturbance is very fast. Disturbance is quick here. Now, if the disturbance is quick, what does it mean? Transmission of sound wave is faster. Sound wave transmission is what? Transmission of sound wave is faster. Transmission of sound wave is faster. Now look about the liquid states. The particles are somehow not compacted as the solid, but they can move and make disturbance. They can move and back to make disturbance, but the disturbance which will make here will not be quick as the disturbance which the solid particle make. Hence here, transmission is between, is not too high, is not too low. Therefore, transmission is moderate. Transmission of sound wave, of sound, is moderate. Look to the gases. Particles are far away from each other. Now, when the particle moves from this point to this point, it takes too much time. Also, when this moves to this one and back again to disturb and cause the sound wave to be produced, it will cause too much time. Now, this means here there is drain. Hence, sound wave transmission is low. Sound wave transmission is what? Is low. Therefore, we have discussed that in solid, sound wave moves very fast. In liquid, sound waves moves moderately, but in gases, sound waves moves very, very slow. Why? Because of the particle arrangement. Because of what? The particle arrangement. Therefore, this is how sound wave transmissions differ according to the media. It is not the same. It is differ from one media to the another. It is differ from one media to another. Now, it is due to this reason now we have different phenomena. Due to the fact that sound waves travel very fast in solid than in gases, we have different phenomena. We have different phenomena. One of the phenomena is if a person standing near a railway, if you stand near a railway, and a train is coming, you can hear two sounds. A person standing near a rail will hear two successive sounds. Why? One will come from rail, which is now the solid, but the other one will come from air, the red one. Therefore, we'll have two successive sounds from the rail and from what? From the air. This tells us what? Sound is transferred differently according to the what? To the media. But again, if now want to hear the distance, the time of arrival of the train to the station, one is you are advised to take your ear to the what? To the rail, so that you can what? You can identify how far the train is, because sound wave transfer very fast in solid than in air. It is very important to put your ear near the rail instead of standing, because there you are going to get the sound from air. But when you put which is late than the sound from what? Than the sound from the solid itself. But also we have so many phenomena which support this. For example, another phenomena which try to show us that sound waves travel very fast in air than very fast in solid than in air is an empty vessel produce more sound than the filled one. The empty vessel, which is this one, produce more sound than the one which is filled with water. Why? Because here the media of transmission is solid. Remember, this is empty vessel. The vessel now solid. But here the media of transmission is what? Is liquid, where sound transfer very fast. Sound transfer very fast in solid as compared to what? Liquid. Have a short break. We are going to resume next time.